Greetings and hola from scooterwest.com here in San Diego, California. Today we're going to go over the differences when reassembling a Vespa 150, 125 motor from the eras of 1959 through 1977. This is meant to be an addendum to the P125 motor overhaul video series we did. It's just a couple differences, and they can hang you up in the process of rebuilding one of these kind of motors. It's a little noisier here today. We're actually doing this during normal business hours. My other tech's actually working on the other lifts here today.
I know for a change we're not doing the midnight tweaker video sessions and actually doing something during normal business hours like conventional normal human beings. But like Robot said, we're going to kind of show and compare some of the key differences with the earlier generation large frame motors that were still very standardized from that good chunk of time, but point out some of the key differences with those motors in comparison to the P-Series motors and stuff like that. So we're going to kind of go step by step and talk in greater detail, but quickly we're going to intro the stuff we're going to talk about. So the first thing we're going to point out is the difference in the leaf springs that keep tension on the kickstart gear and how that's different than the P-Series motors.
And the largest difference is how the actual crankshaft goes into the engine. They use a different flywheel side bearing, and the oil seals are completely different on the older style motors. And it's quite tricky to install these if you've never put one of these in, but I'll show you how to do it without too many special tools, such as we have here.
Another key difference is the kind of older style points, stator plates, and coils that are on those and how those are different than the P-Series stuff. This is an earlier motor that actually had an internal high tension coil right there. And Robot's going to show you what you can kind of do to get rid of that kind of hokey janky setup and actually go a slightly more modernized version with the low tension coil and then the high tension coil externally mounted on the motor.
Differences in the axles and the fly side bearing. So the actual drive axle is slightly different style. This is actually a smaller diameter than the one used on a P125. And they also only shim it on one side. The PXs, they actually shim these from both sides. It's a little different there.
Yeah, but the key thing, like you said, is these axles are not interchangeable because the diameter and the way they fit in this fly side bearing is different. This is that kind of funky, like 3 or 4 piece one that's different than the P-Series one.
And it's already been assembled, actually. The kit includes the rollers, the race, and also the little keeper, whatever you call it. Also, the shifting cross is a slightly different style. It actually comes apart in a couple pieces here. You got the little spindle center, you got the shaft, there's a locking washer in there, and a not shifting cross, and that's how it keys into this whole assembly, and we'll show how to assemble that.
Another key difference is this castellated keeper that actually threads on by the rear backing plate. This castellated keeper is actually left-hand thread, and it actually secures the axle bearing. It's before they started using the circlip back there. So that's left-hand thread. There's a special tool to remove that, and we're going to kind of show the use of that tool and the differences in those right there. And then another thing we're going to talk about is the 3 different kickstart quadrants that are present in those earlier motors, and how this notch kind of ties in to the angle of the kickstart lever, and how there's different splines with a quarter spline, full spline, and even a finer spline, and how there's the different levers that go with these motors.
And one of the last things we're going to go over is a lot of these 125 motors from late 50s all through the 60s, they're quite slow. Most modern 50cc scooters would blow them away. So a popular upgrade is to put the 177 Pinasco kit, and it's the actual direct bolt-on cylinder kit for all these older 2-port engines, 125 or 150, but it has much better porting than the stock barrels. It's a 177cc displacement, and it's a complete kit, includes a cylinder, piston, and a cylinder head. Pretty simple bolt-on modification if you're completely overhauling one of these older era 125 through 150cc motors.
That kit specifically is for the 2-port application. So you can see when we say 2 and 3-port quite a bit, we're actually referring to the transfer ports. So the 2-port motors have transfer ports at 3 o'clock, at 9 o'clock, and nothing at 12 o'clock. During the same era, they did finally upgrade and do a 3-port motor.
On the Sprint Veloce.
Exactly.
Yep.
So the 2-port kit that we're going to talk about is specifically for the 2-port engine cases. And then the last and final thing we're going to touch on is the difference in rear brakes, the way the hubs fit on the axle, and the fact that there's a few different sets of 8-inch brakes based on the application, and there's even a few 10-inch applications during that era. So that's it for the intro. We're going to dive into each one in a little bit greater detail here momentarily. Thanks for tuning in.
All right, so the leaf spring that holds pressure on the kickstart gear is completely different than the PX, where the PX has a well right here that holds like a little coil spring. It's a little bit more complicated setup on these older motors. It's actually, there's I think 5 pieces to it total. You got 2 rivets right here that go through from the outside of the engine case, and it goes through 2 parts of a leaf spring. You can kind of see under here, there's a smaller leaf spring, and then there's the larger leaf spring, and kind of a plate that holds it down, and then the rivets are peened over. This is a pretty robust design. I don't really see them failed, but sometimes if other parts explode inside the motor, it can take this out. We do sell a complete replacement kit for this. Includes all the parts you need to rebuild it, and it's 048000-kit, and it's pretty much includes all those parts to assemble that. All right, we're going to go ahead and stuff the crank into the engine case. That's going to be our first step to reassembling this motor. I've cleaned up this motor pretty nice. It's kind of the original, there's still a little bit of the original corrosion. I didn't go out and get it bead blasted. It's just been washed in a parts washer. Typical of old motors, you'll find pry marks on the gasket surfaces. I had to sand or file some of the surfaces that had nicks. You obviously want to check out all your drain bolts, make sure they're not stripped out. Putting necessary thread repair inserts, before you assemble the motor. This one didn't need it, the threads are still good. This little pin was actually seized up when we disassembled this motor. You can kind of see this motor's got some corrosion, so there was water in it, and just kind of typical of this era motor. Typically when you take them apart, you can take a punch and dry this pin out, put a little heat on it if there's issues with separating the case. Never want to do what some previous shade tree mechanic did, put screwdrivers between here and try to pry it apart. When you take these motors apart, you need to heat them up, because the crankshaft main bearings won't release from one of the sides. Usually you want to heat up this side, and it pretty much expands aluminum in that brass insert to release some pressure on that the bearing. You don't want to take a hammer to the crank and try to pry them apart. There is actually a specialized factory tool for taking these apart, but you don't necessarily need it. Enough heat to the engine case, bring it up to about boiling temperature, 100 degrees Celsius, 212 degrees, whatever, with a torch, and you usually can separate these without issue. But if we have one that's real stubborn, this tool actually bolts to the case and will separate the cases by putting pressure on the crank with this little center punch here. All right, so we're going to put a brand new crankshaft in here. Kind of the best stock replacement crankshaft for this era motor is the Mazzucchelli 150cc replacement crankshaft. Pretty much fits VBBs, VBAs, the American All-States, Sprint Veloce, Super, pretty much any of those 1959 through 1976, 77 era 125 and 150cc large frame motors. I've already pressed one of these bearings on here. You want to put both bearings actually on the crankshaft. This is a new crankshaft. The Mazzucchellis are already trued up. If you're reusing your existing crankshaft, you want to true it. We kind of cover that in the P125 video. Obviously make sure keyways are in good shape. The way to put the bearings on, you never want to put pressure. You never want to put this bearing on and put pressure through the actual crank pin. You want to support the webs when you tap your bearing on. And a simple way to do that, if you have a sheet metal table or something that you could wedge in between here, you know, such as the edge of a metal table, you could actually support the crankshaft. And I have this lovely tool that Steve's had for years. Just probably I'll have some other tools I like using for driving these on, but something that will just make contact to that inner race and tap the bearing all the way to where it bottoms out. So I'm going to go ahead and show you how to put this second bearing on.
And the key thing with these is these style of crankshafts is they use the double-sided ball bearing. So it's the same bearing on both sides. Part number on those bearings is 097804. But because it's the double-sided one-piece ball bearings, that's what makes these engines more complicated to get the crankshaft seated correctly. That's the key thing. It doesn't have the two-part fly-side bearing, and that's what makes this process more critical and more challenging on these motors.
You know, essentially, if you have a steel table of some sort, you could put the crank like that and go ahead and tap the bearing home right there. This little jig is actually a crankshaft rebuilding jig. You know, it's actually specifically for pressing the pins out, but I'm not going to use it for that. I'm just going to use it to support my crankshaft. So I have the crankshaft supported, put a small amount of oil. You know, don't need much, just a little bit. And you could go ahead and kind of get that centered and take a hammer and kind of when it makes that last not so hollow sound, that means the bearing's been seated. With these crankshafts, installing the seal is a little bit more difficult than on a P125 PX style motor. This little sharp edge has a tendency to want to fold this actual seal lip over. You know, it's right here. So you need to actually kind of protect the seal while you're installing the crank into the cases. You know, the factory tools, no one's really going to have these tools. I mean, you could technically make them, but it actually slips over there and it kind of, you know, makes it so there's no ramp for that seal to...
It's a nice tapered sleeve, so everything just slips together.
And there's also one for the flywheel side. But since no one has these, I'm going to show how to do it without these tools here. So instead of using the seal protectors, you can actually wrap enough layers of electrical tape to kind of make a gradual, you know, taper for the seal to ride right up the, you know, that edge right there.
I'm going to be able to tell it in the video what he's done is he's actually kind of left the outer edge of the tape ramping up that lip so it forms that nice natural ramp. So we'll be able to slip the crankshaft through the seal without rolling the lip on that seal. He's going to do the same thing on the other side.
Other side, the step's not nearly as great, but still needs a couple layers of electrical tape to kind of help out. And that's all you need there. And an optional step, if you want, you could actually freeze this crankshaft just to make it, you know, slightly easier to install. I'm not going to do that today. We'll be fine without doing that. So, when driving the seals in, I've already driven the metal seal that's in the flywheel side. You can see it's got metal, like outer, and then the inner rubber lip of the seal. It's actually orientated to where this little oil passage hole lines up with that little notch right there. And there's a couple ways to go about driving these seals in. You could use an off-the-shelf bearing and seal press kit that has like various size you know, inserts. You know, if you have a socket this large, you could go ahead and use that. It's a pretty large socket. You can make something out of wood to drive those seals in. Just something that will drive them in perfectly square, because if you just tap them with a hammer, you're going to end up distorting the seal.
Remember, this is the seal that's got the flange in it. You don't know if you can tell it because we didn't show the seal in its own right, but the seal has actually got a metal flange built in, so it's very obvious which way that one goes. You just want to seat that flange. And then, of course, the seal is actually held in with an interference fit around that bore there, too.
And this is the factory tool right here, just to give you an idea how large it is. It's, you know, almost, you know, like about 55, 56 millimeters. you know, a little bit smaller in the seal, you know, and you can go ahead and pretty much just, you know, use that tool, drive it until it stops. Obviously, you don't want to hit too hard because this is very fragile right here. Our friend Calvin H. Stram, he blew out one of these trying to install one of these in a press about 8 years ago in front of a customer, of all people.
That was a long night for Kevin.
Yeah.
And then of course, then the clutch side one, it's the same. It's the more all rubber one. It's got the same notch for the oil passageway. Those are a nice kind of hint, makes it so you can't really put them in wrong, but I think we're gonna use the same tool, right, Robot?
Pretty much the exact same style tool, or like I said, if you made something out of wood, off the shelf bearing and seal press kit would do the same exact job. So pretty much, you know, this has got the little tapered spike that kind of holds it in place. I got my little notch right there. Use grease or oil. And one thing on the engine case, I never took the circlip out. This circlip's pretty difficult to remove just because it needs a specialized circlip remover because the gap's quite far right there.
But you'll notice that circlip is basically the stop for the seal.
And that's pretty much, we're going to drive the seal until it stops right there. Again, keep in mind this notch needs to line up with this oil control hole right here, or this oil hole there.
So I'll hold the engine case. It sits nice and flat on the clutch cover with it removed. And you'll see Robot's lining that notch up, getting it centered.
Sometimes get it started by hand. Make sure it's going square. You can kind of see I'm working the actual seal driver, you know, in different directions to make sure it goes square. And that's it right there.
And then you can see the notch is perfectly aligned and that seal is installed. Hey, what's going on? Moving on to the next key difference, we're going to talk about the axle bearing in the fly side case of the engine. On the P-Series motors, it's a kind of needle bearing that's a one-piece design. On these earlier motors like we're talking about here, it's actually like a four-piece bearing. It all comes as one kit. The part number on the kit is a 047160, but that kit's going to consist of this sheet metal cage, the actual rollers, and then the outer washer and then the inner washer. And a little tricky to kind of assemble and install, but very doable. Again, you're going to use the same kind of tools. If you got your generic bearing and seal and drift set, you use that to kind of tap everything and then make sure it's all good. One key thing that actually makes the overhaul and repair and sourcing of parts a little challenging on these motors is the fact that because the inside diameter of this bearing is actually larger, it makes it so the portion of the axle that actually rides in there, these are actually different specifications post like 1973, 1974. So about 1974 was the first year they went away from this design and went to the more standardized design that you'll find in the P-Series and rally motors and stuff like that. But it makes it so the axles are completely not interchangeable unless you were to modify, you know, this dimension here by either turning it down or putting a cap or a sleeve on it in some capacity. But that's the key thing. Don't let the axles get damaged on these earlier motors because they're unobtainable. Another difference on the axles, 3 and 4 speed axles are actually the exact same. This one's already pre-assembled. You can see the first gear on the outside there. They have the axle spacer just on the outside.
Went from a first over to a second over shim to get it within, you know, pretty much you want it above 0.2 of a millimeter and less than 0.4 of a millimeter is your ideal clearance for that once you have the circlip installed. And again, on the PX125 video, we show how to mic out that space there.
So kind of extending on the axle a tiny bit, we're going to show the differences in the actual shifting cross and the shift selector spindle. The P-Series motors, like you'll note in the other video, is just kind of one piece here that threads into the axle. On these earlier motors, there's the spindle, the special locking washer, the spindle spacer, and then the different style cross. Part number on this folding tab washer is a 013768. The notch shifting cross, which is these are commonly referred to as, and you can see the notch there on this side, as opposed to being completely flat where it threads together, it's actually notched. And that notch actually fits in the, married notch of the Selector spacer. The part number on these earlier crosses is 094944. And again, these notch crosses are present in motors in 1959 up until 1973. Key thing to remember is the notch crosses tend to go with that style of axle and that style of axle bearing. All those components tend to be kind of married together from that same era. And again, none of that stuff's interchangeable with the stuff that came later.
All right, we're gonna go ahead and install the shifting cross. Actually hit the edges with a belt sander here, just to kind of take off some of the burrs on there. And as you can see, there's a rounded shaft or pair of shafts, and then there's a square pair of shafts. And if you look at this, all 4 notches, do you notice anything different between any of those 4 notches?
Do I? Actually, I've never looked at it that closely, to be honest.
Okay, this one's actually machined a little higher, or ground a little bit higher. So I have that little notch that's ground a little higher facing towards you. And I'm gonna go ahead and install the shifting cross, kind of fish it through, put the one square side up towards the front half there, and then twist it. And it will only twist in that position. And again, the notch part of the shifting cross is facing up here.
Let's go ahead and slide it all the way up just to show everybody. You can see it in there. The notch is facing up, which is obvious because of the way the next piece is going to thread on there and drop down in place.
And you can actually hold that right there and kind of feel right when it engages the notch right there. I'm holding it.
I'm going to put the locking tab washer on the actual spindle itself, and keep in mind, one of the few fasteners that is actually left-hand thread, reverse thread. So instead of righty-tighty, lefty-loosey, it's the opposite. So you can see robot threading that thing down.
And make sure it moves freely. Sometimes you got to deburr the shifting cross a little further. You can either put this in a vise carefully, or I'm just going to put a screwdriver right through the shaft. And the one thing is you can't use a regular wrench. You need to either have a filed down 13mm wrench, or just, I don't know, one that came with an air tool of some sort, or the toolkit actually with your Vespa would have the thin stamped sheet metal wrench if you still have that. So pretty much just kind of snug that down. It doesn't need to be overly tight. And there you go.
And you can see he's kind of made a point to kind of keep the, see if we can get that on the camera.
It's actually wrong right there, unfortunately.
Is it wrong right there? Oh,
Yeah.
It doesn't matter, huh?
Yeah, well,
Oh, sorry.
it doesn't really matter, but it happened to be where the 2 flats lined up. So the tab washer, since the 2 tabs line up on this side, the tab washer is going to go down to the single flat on this shaft. So we're going to take, a punch of some sort and fold that down that direction, or even a flat bladed screwdriver. Usually I use a punch, but I don't care if I've ruined the screwdriver here. Just tell the tool guy he owes me another one. So pretty much Steve's going to hold this. Not the most ideal condition doing it right on a table. Usually I'll do this in a vise. And it's a pretty soft washer. Again, this isn't the most ideal spot to do it. I'd prefer to do this on a vise of some sort, but.
Grip and rip it style.
Yep. And then the other side tab washer is actually going to go, and it's going to want to, I'm going to actually bottom that out. You could use something to hold it. I don't know if you can see what's going on here, but pretty much repeat.
I'm going to do it from the side. So just folding that soft metal locking tab washer down on both sides around that notch.
There, you're done.
The one side there, up on the one side and down on the other, right, Robot? That's what you recommend?
Yep.
So now we're ready to actually drop the gears on this axle and install it. Don't really need to go into that because we talk about that in detail in the other video.
All right, so I got Mom's hot plate out from her kitchen here, and this is kind of the safest way to heat up one of these engine cases, to prepare this part of the engine case to install the crankshaft. One thing I did do is you want to protect that newly installed seal. I just actually used my seal driver to kind of keep the direct heat of the hot plate off the seal. There's other ways to go about it. You could put foil, like a couple foil balls in there. You can use the silver tape that's used, for heating and ventilation. It's like kind of a silver tape, kind of protect the seal. Thing's playing hot. You know, pretty much I spit on it right now. It sizzles.
And how long has it been on there, Robot? And like what heat setting are we on?
I set to high. You want to watch it. Don't really want to bring this over 250 degrees Fahrenheit. You know, 110 Celsius at the most. Got the hot engine case off the hot plate. Got the flywheel side, the clutch side. We want to install the clutch side. And I have grease on the shaft and pretty much wiggle it right in. And if it's hot enough, it will go all the way in and seat. And that's it.
Key thing is to do it fast and get the thing nice and hot. It sat on the hot plate for about 15 minutes on high. And then of course we protected the crankshaft with grease and oiled everything up before we slipped everything together.
Never want to use a hammer to put these on. You end up throwing the crank way out true or damaging the crank. So you can see it's all the way through. You can remove your electrical tape now. And we'll go ahead and put all the other goodies inside this motor. All right, I'm gonna go ahead and install the wheel bearing. The engine case is still pretty warm. Again, you could use like a large socket that's pretty close to the same outer diameter as this. Make sure it fits in there without damaging the threads. This is the actual factory tool. Steve's gonna put a little pressure on it. There you go. Hear that? The noise change, that means the bearing's all the way in there. We're gonna go ahead and use tool Castle. This is a custom machined tool that's specific to this original castellated nut that holds that bearing in. And you can see it lines up perfect. This is reverse threads right here. Make sure you don't cross thread it. And the idea is you don't necessarily torque this to any particular torque, but it needs to be snug. And one of these slots needs to line up with a line on the case. So I'm gonna go ahead and get a wrench on this and we'll give it a little crank.
Remember, there's actually two different sizes of these castellated keepers. I believe the GSs and SSs, even the Supers have the larger diameter one. Cool thing about this tool is this tool actually works on both of them. These are made by a Vespa enthused machinist out in Colorado. So we're thankful to actually have these available again. And again, this thing actually keeps that bearing in, and again, left-hand thread. So Robert's pushing in the rear seal there. Doesn't require much tapping at all. Goes in pretty effortlessly, and then he's got the clip there.
Engine's still a little toasty right here. It's a little hard to do without me being right over top of it, but you kind of put the little kind of tang in there and just work it in there.
No tools and a scalding hot motor.
There you go.
Robot.
And the clip just snaps right into place and you're done.
Okay, so another thing we talked about in the intro is the fact that there's various different kickstart quadrants and levers. And for the most part, the levers either go with the actual model of the scooter, the engine of the scooter, and or of course the quadrant. So this is actually one of the more common ones. It's the quarter spline quadrant. And then there's two different levers. There's actually the quarter spline short lever and there's a quarter spline longer lever. The shorter lever is on a lot of the 8-inch applications, the Supers, the VBBs, the VNBs, etc. The longer one would be common on GS 160, SS 180, as well as Rally. And the cool characteristic to this is it's got the classic straight curvature. Remember on the P-Series engine rebuild we do, the P-Series levers kind of curve up and then they kind of angle and they've kind of got like a compound angle to them. These quadrants will interchange in any of the motors, but you need to be careful that this notch that this bolt accompanies, that these kind of stay paired. We've seen instances where people have tried to put like the more classic style lever on like a P-style motor and it won't work unless you change this quadrant. And then of course there's the earlier style quadrants. Hopefully you don't have these, but if you do, it's not the end of the world because you still have quadrants available as spare parts as well as levers. But I would say years maybe 1958 to like 1961, 62, they actually had a finer spline that was all the way around. And of course the finer spline where this actual kickstart lever is gonna mash, it's definitely gonna be more susceptible to stripping out and everything. We talked in the P-Series video about that O-ring that fits down in that bore. We've already put a new O-ring in. Before you install this thing, generally you want to Put a little bit of grease on this, and this just actually drops right in. There's of course the 2 rubber buffers, part number 046742, bang and bang, that are standard on all these motors. You always want to replace those and make sure those are new. And then that just pushes in. You take the spring, go over this in the P-Series video, I haven't done this in a while, but you take the spring over the shaft there, and in general you can actually just pull that thing right into place, and that's how you install that that quadrant. So that's done, and there's going over the few differences with the quadrants and the levers. So Robot's installing the 4 gears on the axle. He's paying attention to put them in the right orientation. He's using the cush drive as a bit of a cheater to make sure everything kind of lines up perfect. You can also too use the wear marks in the axle sometimes. We talked about in the intro, we've already fitted this with the second oversized shim. Kind of talk about that in the other video as far as how you check that. So Robot's ready to bang this thing all the way back together. And that's almost about the last things we're going to do on this half of the engine before we actually close the thing up. While he's got it out, you never want to forget the kickstart gear. Another thing is there's actually several different kickstart gears for these engines, depending on 125, 150. And the differences are the number of teeth as well as the actual diameter of the bore because of the different cush drives that it fits on.
Mostly 13 or 12 is generally the 2 different ones, but definitely not interchangeable there.
Yeah, not sure. The key things to remember if you're ordering the spare parts, to count the teeth and check the bore. Robot's kind of lubing everything. So I spun the bearing and squirted up with some oil. All the other spots are kind of greased up, so in theory it'll go back together pretty smoothly. And again, we're going pretty quick in this one because for the most part this stuff is the same as the other video we're doing, but Robot's using some Indian head shellac. He's prepping the gasket. We've got the other half, the fly side case half, sitting on the hot plate so we can kind of carefully push this back together.
I like always using the back side of the gasket, packing it. Seems to work pretty good. Flip it over.
All right, so you notice we've got the fly side case half sitting on the hot plate. Notice the way it's positioned on there. And then we've also, of course, been protected in that seal, which we installed earlier. So I'm gonna grab this thing with this rag here. Hand it off to Robot since he's wearing the gloves. I've got the oil, I'm gonna squirt that up a little bit.
See how hot the cases are. The oil kind of just waters right around. And kickstart lever is actually just temporarily installed. We're gonna go ahead and, oops, a little drizzle of the oil there. Go ahead and first line up the crank and then drive it over there. And you're gonna wanna kick it and give it a couple taps, just much like the P200. But the problem is, you'll see sometimes this shaft isn't lining up perfect. You just gotta work it, you know, just like work with it. And then also there's a little bit of friction of the bearings going. There we go, now it's starting to go down. Just little taps, that's all you wanna do to get this down. And make sure nothing's binding. Like right here, this is not quite lined up. Let up a little tension here. There we go. So sometimes, you know, this shaft actually moves around a little bit, you know, until it drops into place. And I kind of felt it just drop right in. And there you go. And it's kind of on the last little bit. All right. So the next step is I got 7mm new flat washers, split washers, and nuts here. Everything's nice and hot still. And I'm just putting them on these permanent studs. This stud's actually still here. Normally this is a removable stud, but on these old engine cases, sometimes they get seized into place. So.
All right, so we're actually drifting this alignment dowel back in. Remember, Robot mentioned to drift that out in order to easier separate the engine case, especially in this case, because this thing was very oxidized and rusted. So now while it's still nice and warm, we're gonna tap that down right there till it's flush, right?
And go ahead and just snug these down. You're gonna go in like a crisscross fashion. It's gonna pull the case all the way back.
And we're just doing the 4 key fasteners where the 2 crankcase halves come together around the crankshaft.
And much like the P200, P125 video, pretty much the same thing. You got, I think there's 7 of these short studs, and there's the 1 long stud that's already in place. Electric start motors. I don't even need to talk about electric start motors because they didn't have electric start in these days. But some of them have an extra stud on the P motors. So Steve's helping me out here.
Drop some of the studs from your robot.
All right, cases are all closed up, and all the fasteners that hold the 11mm headed 7mm fasteners are all torqued down to spec, much like any other Vespa motor. You want to check how this rotates, and it actually rotates pretty nice. And there should be just the ever so slightly small amount of free play. You could set up a dial gauge to see if you have about, you know, a half to 1/1000th of free play end to end, but you could just ever so slightly feel it. And if it binds, you know, it definitely needs to be, you know, the crank needs to be floated. And essentially to float the crank, you only do some real small taps side to side, you know, just to kind of relieve the pressure from the bearings in the case. You know, it doesn't take much. And you could just double check it. And I could tell it turns even ever so slightly better. And I could just feel that real small amount of free play. And that's what you want. And again, make sure rotary valve's not binding. If everything's right and it turns freely with only the resistance of the kind of oil seals on the actual crank itself, you're A-okay.
Good sign. Lots of feel. And another thing we remember it was hanging a little bit on the rotary pad intake before the fly side case half went back together. What effectively happens when everything got sandwiched back together, that kind of trued up and straightened up the crankshaft. And then just watching robot there, just a tiny bit of touch and finesse till you get the right amount of feel on those bearings and stuff like that. Now we can safely remove the electrical tape that kind of kept the seal lip from getting rolled over. That's an awesome tip in its own right, for sure. And from this point forward, what, top end, stator plate, flywheel?
Yeah, much like the P125, you know, of course, no electronic ignition, so you need to set the points and timing.
All right, so in the intro we talked about the differences in the stator plates. Ironically enough, the stator plate bases are actually completely interchangeable for all these motors. Basically, again, 1959 to about 1977. Of course, the differences in the coils will change based on the electrical requirements of the scooter and the various applications and the models and the eras, of course. This is an earlier one. I think this is like an early 60s one, right, Robot?
Yeah, like 62.
62 or thereabouts. But what we've gone ahead and done is have actually removed the internal high tension coil that was common on these applications, say 1959 up till about 1964, 65, until they finally went away from that. The externally mounted high tension coils are definitely a more robust electrical system, a more robust ignition system. But you can see we've got the new standardized condenser, and the part number on that's a 155973. There's 2 styles of the points. There's the posted and the non-posted points. The differentiation in year of that is about 1972, 1973, thereabouts. To be totally honest, you can always use the posted points or the later ones, and those will interchange on the earlier stator plates. You just have to drill out and remove this like little threaded brass post there, and you have to drill it out ever so slightly to fit the posted points on a non-posted stator plate application. Ironic that I'm talking about a stator plate that much, especially with Robot standing here, because Robot is definitely probably the Western Hemisphere's foremost expert on the nuances and various differences within the stator plates. So Robot, what else can you tell us that I didn't really touch on?
Again, you know, here's your external or internal high tension coil. They're a little finicky. You know, the replacement coils are available, but I don't really speak all that highly of them. Any bike that comes through the service that I'm gonna do a complete overhaul on, I usually replace this coil with the internal style. And that part number on this is coil-03, and it's just the replacement coil, pretty reliable. This is the little yellow wire that comes off it, doesn't have a terminal on it, so you're gonna have to crimp a small ring terminal on there that ties to the points. You can see it pretty much wires exactly the same as this internal coil here, but you don't have the high tension wire that passes through the hole back here. And you can actually plug that little hole with a rubber plug. You can see on this engine case, they have the bracket mount for the external coil right there. So you're going to need to also order the external coil.
Part number on the coil is 244114. There's a few different variations and there's lots of different styles, but for the most part, the high tension coils are the high tension coils. And then of course, there's the original Bakelite style ones as well, that are kind of the more brown, they're the kind of brownish, more oval teardrop ones that are kind of the more era correct ones. But all those mount directly to the back of the motor in the exact same fashion.
And I can show an installed coil right over here on this other motor.
Whoa.
So this is the aftermarket, kind of the less expensive coil. It works perfectly fine. Includes a spark plug wire and an old style clip. Put a new rubber boot on it. And so what you need to do is run a wire with a 1/4 inch quick disconnect terminal, and it ties to your ignition kill switch wire, which is the red wire coming off the points. And then you instantly have the external ignition coil set up for one of these. And of course, you got a little bit more to that. You got to, set your points gap and then go ahead and set your timing. You got to find top dead center. We have another video on setting the timing on these vintage Vespa motors. Sometimes it's a little hard to wrap your head around it if you've never messed with timing or ignition points, but once you grasp the idea, it's real simple actually.
Watch the videos and Robot will help you out from your home computer. Absolutely. Okay. So we talked about the fact that we're going to be installing this very, very nice complete top end from Pinasco on this particular engine. We're going to kind of show quickly the original 125 top end. You can kind of see it there in my left hand here, and here's of course the Pinasco one. You can instantly see the difference in bore going from 125 cc to this Pinasco kit is 177 cc. When it comes to comparing the pistons, there's the difference there, you can kind of tell. And again, what they do with the Pinasco kit that's cool is it's a 2-port, fits to the 2-port crankcase, but they actually add a 3rd port within the piston, which is really what kind of helps boost the performance on this one significantly. They used a similar style of top end on the Vespa ET3. That was the ET3 stood for. That was the small frame that had the 3rd transfer port. And that 3rd transfer port aligns on the inside here, which you can kind of see. Whereas in the old 2-port cylinders, they don't have that. And the other thing you'll notice, since we got it upside down, is the general same size of the actual transfer ports in the way it mounts to the crankcase. You don't really need to modify the crankcases at all with this beautiful cylinder that's from Polini. It just bolts right up there. Pinasco, I'm sorry. Sorry, Polini. Whoops. Pinasco. But you notice internally within the cylinder wall, the size of the fact that they kind of add that like kind of boost port there to increase the porting on this thing. And then of course at the very bottom, I don't know if you can see it on the camera there, but you can kind of see the 3rd transfer port that's on the Pinasco cylinder and the fact that it's not on the old junky 125 or 150 cylinder for that sake. If you look at the top of the cylinders, there's actually several different cylinder head versions of these particular engines as well. There's the 125 cc ones with kind of the larger flange here for the smaller bore. There's 150 cc ones as well. And then there's the there's like the dome topped and deflector top pistons, but these are very low compression cylinder head, right? And then some of the later ones actually didn't have the lip that was quite as pronounced. It was actually a flatter style, and they didn't have the cylinder where it recessed down into the cast iron cylinder. It was a flat cylinder head. Those are a little bit better performing. Again, era on this particular stuff, what did we say, Robot? 62, 63?
Yeah, 60, the very early 60s and 50s ones had a deflector style, real odd looking piston. And the more, this has the more avant-garde dome top piston.
Also included with the Pinasco kit is a completely custom cast aluminum cylinder head, specifically designed for the new uprated larger displacement cylinder. So that's included. You get a new cylinder base gasket, and you get high quality, like those are like 1mm rings, Robot?
Yeah, 1.5
1.5mm rings, and the upper ring is the real nice Dykes or L style of ring, and you can kind of see just the kind of improved quality in the piston on these things.
And these kits, 2 other bolt-on items you want to use with these kits is Most of these older, especially something like an Allstate's only going to have a 15 or a 17 millimeter carburetor on it. GLs, all those VBBs, they don't have 20 millimeter carbs. The later 125, 150s had a 20 millimeter carb. So I would replace the carburetor with the 2020 Delorto downdraft carburetor, and it needs to be jetted accordingly. Also with the pipes, some of those early designs with the real short header aren't very efficient pipes. An ideal stock replacement pipe would be the Sprint Veloce pipe. It's got the long header, or with some modification you could put the SIP 4-road pipe or even a P125 pipe. You know, you need to cut one of the brackets off to use that style pipe, but they're much more efficient, but look very much like a stock exhaust.
One final exhaust you can actually use the super exhaust, which are effectively about the same as the Sprint. Those are a good option for a bike that's still running the 8-inch tires, just because of the way that they kind of hang from the swing arm and stuff like that. But the super exhausts have that longer header. So anything you can do to get away from that early exhaust that was common on 1959 to about like 1966 motors will generally help the performance that you're gonna gain with this high quality Pinasco cylinder.
And last little chime in is my brother.
That's right.
He bought one of the first Pinasco kits off us years ago. He runs a shop that does dyno tuning, and everything he owns he can't touch. He's got to trick it out or do something to it. So his Vespa GL, that's all bone stock. He bolted the kit on. I think he's got a Cedo Plus 125 pipe that they're actually pretty difficult to get nowadays, and a 20 millimeter carb, and it's been jetted in time, pretty good, and on the dyno, and I think it makes 2 horsepower shy of a P200. So it's pretty fast. It's almost as fast as a P200. I've ridden the scooter before.
Pretty impressive. Thanks, Pinasco. All right, so another thing we're going to talk about is the various differences in configurations of rear brakes, backing plates, drums, etc. So we've got 2 motors, the one we've been working on, obviously, and here is a motor that's slightly older, maybe like a 1960-ish or about. And you'll kind of commonly hear us ask you when you call for parts, if it's single post, twin post, as far as the rear brakes. Some of the real earlier bikes, I say 1950, well, going back before 1959 with the wide body motors, like those were most commonly a single post 8-inch rear brake. They kind of carried that over into the more standardized engine designs, early on only. And you can't really see it, we're not going to take this one apart, but if you kind of zoom in here, you'll notice that there's just a single mounting post on this backing plate. And those single post brake backing plates were common with this 2-part hub. The later ones, and all the 8-inch VBB style motors have this 2-part hub where there's the cast aluminum steel lined drum and there's the central splined hub. As far as the central splined hub goes, there's 2 different variations. Commonly, the single post ones had a finer spline, and commonly the smaller diameter studs. These actually have the larger 10 millimeter studs on both of them. So this actually could be, there's a few weird variations where there was a fine pitched spline with the larger and smaller studs. When we kind of work this way, you'll notice we've got this one a little bit more exposed, positioned in the same orientation, but you'll notice we've got a nice powder coated 8-inch brake backing plate with the twin post brakes. And these are the brakes that would go on this particular motor. Again, the twin post. The single post one we were talking about on this other side, instead of having these 2 posts, they have a thinner brake shoe and just a single post. And then of course, this is the hub and the drum that fit to this, and these are 2 different pieces. They're held together with these flathead screws that kind of secure the drum to the actual hub. This brake configuration is common on any of the 8-inch VNB, VBAs, VBBs. When they went from the 8-inch VBBs to the supers use a very specific set of rear brakes. Again, that's an 8-inch bike. It is a twin post, and it uses kind of a funkier style of like cast aluminum 1-piece drum. And then of course you've got the Sprint 150s that use the same block that we've kind of talked about in detail, and they use a 10-inch backing plate and a backing plate and rear brakes that are the exact same as say like a run-of-the-mill P200 P-Series bike. What you got, Robot?
One thing to keep in mind with these twin pin 8-inch bike. Some of the gearing may not be right for a 10-inch wheel, but it's pretty easy to convert these over to 10-inch.
So again, there's the 8-inch one, and then go ahead and just drop the 10-inch one over it.
And you can put a 10-inch, you need the 10-inch backing plate, as Steve suggested, 10-inch shoes, and also a 10-inch rear drum. And if you really want to go far, you could actually change the gearing, the correct gearing for a 10-inch
But
tire.
it's just nice to show you how interchangeable and flexible the Vespa stuff really has always been, and in particular for that good, 20-year period, basically. Smart design. So 8-inch, 10-inch. I think that's about it for the differences in the rear brakes.
Single pin, you're not going to be able to convert to this 10-inch, unfortunately.
That is true, actually. And again, I would say single pin was phased out about 1961, maybe 62 or thereabouts. All right, so we've gone ahead and replaced the 2 O-rings that are on the brake cam. Pushed that back in, we slid the lever on, put the cotter pin in, and of course put the return spring on. Ready to drop the backing plate on. Drop that on. There's these 3 screws that are kind of prone to breaking or stripping. These ones are actually in pretty good shape. These hold the backing plate on. All right, there's one thing we actually failed to mention that's definitely very different in these motors. We failed to mention the intro, but we caught it. We're going to mention it now in regards to the clutch. These are all non-oil injected bikes for the most part, and as a result, they've got a different height clutch. These are actually a taller clutch, correct? Mm-hmm. And it's very important, we'll have Scott pan in here, that this spacer washer, this thinner one, goes on to protect the seal before the clutch gets installed. On the P-Series motors, it's actually a thicker one, and it's actually like a gear that actually drives the oil pump. But there is interchangeability issues with older clutch components and newer clutch components. And the older clutch components, the overall taller ones, aren't really available anymore. So if you're putting a P125 or whatever series later clutch in one of these motors, you need to make sure that you accompany it with the thicker washer. Robot's kind of moving on to replacing the bash bushing, but that is one key thing we forgot to mention that is definitely different on these earlier motors. Overall difference in heights of the clutch. We've got this about as far as we're going to take it for the sake of this video. From this point forward, for the most part, everything's the same as the P-Series. And if you've got it this far, you can definitely complete it the rest of the way. So that's it. Thanks for watching. Steve, Robot from Scooter West and Vespa Motorsport here in San Diego. Again, finalizing and going over differences and nuances between the earlier 125, 150 motors in comparison to the P125 or the P-Series motors in the other videos. Thanks for watching. See you later.